Hello, I would like to show you my measuring device that I'm working on right now. This is a spectrometer, and it's built from simple materials. This is a plastic box that needs to be tight from the light, and the input for the spectrometer is a socket for the toslink cable that you can easily buy. And it works from my first experiments from UV light to deep infrared, so it works fine. And inside you can see that we have small amount of components. The input light is going to the diffraction grid, yes, and the webcam is catching all the light. I know that I need to add the magnifying light loop because I need to spread the spectrum for the better sensitivity to whole width of the sensor. And for the diffraction grid I bought real diffraction grid from internet. It is 1000 lines per millimeter, and as you can see there are some example spectra of the certain transmitters, lamps, the LED lamps also. What next? Well, as you can see, it's built from the plastic, so temperature coefficient of the material is important, so it will work probably in the temperature where I build this device, but in the change in environment it can shift little. The light input from the front of the device, it's split by diffraction grid, and it's spread to the whole wing width of the sensor. And the light is divided by nanometer scale, so you know what type of the light is going to the device. Then you can check if between the known source of light, let's say tungsten lamp, you put some chemical compound, then you can probably will see the absorption light of the certain chemical components that are inside.
Hello, I would like to show you rest of my work. As you can see, I made sketch in 3D software to have everything aligned in the proper height. I start with the base plane when I sketch some holders, adapters for the less optical instrument. One for the magnifying glass, one for the webcam, and also for the diffusion foil. And the light is represented by this magenta color, and input the whole system from the front. And in reality it looks like this. We have the plastic box that is painted black 3 times because I have light pollution, and also I add foam in the front to be sure that there is no not proper light input to the box. Of course, box has also black lid. And over here we have the optical components that are how it works. So you can see the program that is running right now, and it's positioned to the cold LED lamp. When I switch the temperature of the light, now it is more warmer. You can see that the light shifts from the, let's say, center to the right. And we turn on the cold light, very warm light. You can see that it's even greater. Of course, you can also check the monochromatic wavelength. And theoretically, the green laser pointer is one of those. I try to start it. It has very weak batteries, so. As you can see, we have some light input to the system, and the green one especially near 520 or 31 nanometers, and also we have something strange because we see something in the infrared length. It's 34 nanometers, and when I start to search why I have this phenomena, I read that the green laser is not really green because it started life as 800 nanometer laser. It's going to some kind of crystal that changed the wavelength from 800 to 1064, and the next crystal is divided those wavelengths by half. So at the end we have more or less 532, that is green color. And basically that's it. Now we can make measurement. Of course, after adjusting everything mechanical inside the box, you have to also adjust everything in the software. But the Termino spectrometer is a very nice piece of software for the Windows. It's very simple and it works like a charm. This orange box you have to adjust to have the proper position of the sensor to the grating